So you will hear me use the terms human systems engineering and human factors pretty much interchangeably. That may change over time, but at least for now, I think we can often think about those two things as more or less being synonymous. So forgive me if sometimes I refer to human factors engineering and human systems engineering as including the same material, but they really, for the most part, do. So there was one of the fathers of human factors named Alphonse Chapanis, and he once described human factors as this way. He said, "It's easy to make things hard, but it's hard to make things easy." And that's largely what we're trying to do in the design of our products and processes and so forth. We're trying to make things as easy as possible. Unfortunately, when we design things, and especially when we're focused on all the technological aspects, the default is actually to make things kind of hard to use. And we're trying to do just the opposite. So in order to make that happen, you have to approach the design for people with the same amount of rigor that you approach the design for, say, electronics or mechanical aspects or any number of other things. You have to have a rigorous approach to it. In addition to that, you need to know an awful lot about your topic area. So just like electrical engineers need to know an awful lot about electrical stuff and electrons and wiring and all of those other kinds of things, human factors engineers or human systems engineers need to know an awful lot about human beings. And that includes how they make decisions and how they learn and how their memory works, how they behave in social groups and the like. All of those things apply to the design of business kinds of principles and engineering kinds of principles. So, the actual title, or I should say the actual definition of human factors is that human factors studies and applies knowledge from all human sciences to improve the match between people and the world through the design of products, processes, environments. So let's start with the important parts here. So it studies, so it's a science, and applies, it's an engineering field, knowledge from all human sciences. What I mean by human sciences are those things that focus mostly on humans, like biology, psychology, anthropology, sociology, all of those kinds of ologies that want to be used in order to improve the match between people and the world. So to a large degree, people are at a mismatch between the designed world around them and themselves. In other words, we didn't evolve in an environment like the technological one we're involved in now. Instead, we evolved in an area where there were really small groups of people. The small groups hardly ever encountered other people, or at least not very often. They were constrained in how many miles, for example, they would ever travel in a life. Their lives were short, and now things are really quite different than that. And it shouldn't be surprising that people have a difficult time understanding technology and learning it quickly and so forth, simply because we haven't evolved under those kinds of conditions. So as a result, we're trying to understand the world with a brain that's the same, more or less, as it was evolutionary wise, as it was hundreds of thousands of years ago. So that's the big challenge. Now, in order to fix this, or to at least improve it, we need to understand human behavior, human limitations, because there are limitations to our abilities, and other characteristics about people. If we can understand those, then we can design products that are a good match to how people actually behave, how people actually learn, and how people actually think. So the goal of human factors then is to make our interaction with systems, products, and so on, ones that enhance performance, increase safety, and make us more satisfied. If you look at commercial products, they tend to have three characteristics in common. One is they're useful. That is, they enable us to do things like, let's see here, choose that. They're useful, there we go. They enable us to do things that we couldn't do without the product. An example of that would be an automobile. We could not get the places we go as quickly as we could and so forth without automobiles. As a result, those things are useful. But imagine when the automobile first came out, the automobile was actually rather difficult to drive. And in fact, it was sold with its own toolbox. And typically you had professional drivers that would drive you around when automobiles first came out because they were so difficult to use. And in fact, they didn't even have things like steering wheels. They had these levers that you would pull and push in order to move the wheels around. So that doesn't sound very usable. What I mean by that is it actually is hard to kind of make this thing work, even though it's useful once it does. So over time, products became more usable as well. So now products were useful and usable. Suddenly we had things like steering wheels, and we had the ability to start the ignition without having to crank the ignition and so forth. And nowadays, if you look at cars, it's sort of assumed that the cars will be useful. That is, they'll work and they'll be usable. I ought to be able to kind of get around the product and understand how to use it. But now they'll be desirable as well. So desirable really focuses on kind of emotion and motivation. But you'll notice the scope of human factors sort of taps into all of these things. How do we understand, hey, what would be useful to people? What would they really like? Then how do we make that easy and accessible for people? And then how do we really want them to actually desire it? Because for a product, it has to meet all of these things in order to be a good design. So if you look at the scope of human factors, there's really a couple ways we think about humans and their interaction with products. One is from a perceptual standpoint. So when I say perceptual, what I mean by that is sort of their ability to see, to hear, to touch, etc., the product. So some things are difficult to see, and as a result, text, for example, small text with very little contrast and so forth is hard to see. As a result, that can be fixed. From a cognitive standpoint, certain things are hard to remember, they're hard to learn, they're hard to make decisions about. A motivational standpoint, how do we design things so people are actually motivated to use them? Emotional perspective, how do we design things that people feel good about using and want to tell other people about using it? There's physical components, for example. How do we design things so that small people can reach everything and so that really large people can fit? Those are important physical characteristics. How do we design something so that it's easy to carry? All of those things are related, of course, to human factors. How do we design things so that one part of a process follows really easily and sort of seamlessly from the previous part? How do we design things like communication strategies and organizations and teamwork so that it sort of fits with our natural social tendencies? And then finally, how do we design things from a cultural standpoint so that it sort of adheres to the things that we value as a culture? These are all parts of the scope of human factors. So you can begin to see that the toolbox for human factors has a lot to do with those components of the human that we can sort of study, understand, and then even improve. One thing that's worth mentioning is what human factors is not. Human factors is not just applying checklists and guidelines to the design of things, and it's not just using oneself as a model for the design of things. So the reason checklists and guidelines don't work terribly well is that there's just too many sort of characteristics about people and too many environments and contexts in which we can use products and processes. You couldn't come up with a checklist that's quite big enough to cover all of those kinds of things. So as a result, whoops, I need to go back. I'm trying to operate my pen here. Didn't work. I'm going to try that again. Yeah, I'll stop trying to mess with my pen and I'll get back to work here. As a result, you couldn't come up with a checklist that was big enough. And human factors isn't just using yourself as a model for designing things. People vary wildly in their abilities and their interests and so forth. So if you're designing just for yourself, you're really designing for one person. And of course you're going to need more than one person to buy your system in order to actually make a go of it financially. So as a result, we need to be studying a fair number of people and lots of different kinds of people in order to make this work. So during World War II, the U.S. Army used lots and lots of psychologists, and typically these psychologists were used to select the best participants and to sort of assign them to the jobs that fit them most appropriately. So for example, you might administer a bunch of intelligence tests, and you might take the results of those tests in addition to a couple other personality tests. So for example, things that measured things like willingness for taking risks. And you might take those pieces of information and assign people to various jobs. So you might take the people who scored quite high in two areas, one being intelligence and the other being sort of daring, and take that person and assign them to be a fighter pilot. You might take another group and assign them to be bombers, take another group and assign them to be transport pilots, and so forth, right? Well, they were doing that during World War II, but they ran into a problem, in particular with their bombers. One of the things they recognized is that pilots, after they landed, at exactly the time they should be engaging their flaps, instead they retracted their landing gear. So they come down, they touch the tarmac, they're moving along nicely, just coming to a stop, and then just at the moment they should be coming to a stop, they retract the landing gear. Well, that was kind of silly. And in fact, what would end up happening is the plane would go end over end and unfortunately destroy the plane and kill the pilot. So they thought, boy, something's going on around here, something's a problem here. And they brought in a psychologist to sort of look into the problem, and at first they asked the person, would you improve your selection criteria, because these pilots aren't very smart. They're doing something like when they should be engaging the flaps, they're retracting the landing gear. So a psychologist, I think it was Paul Fitz, went in and looked at what was going on. And one of the things he recognized was that if you look at the design of the cockpit, the switches controlling the flaps and the switch controlling the landing gear were right next to each other. And these were almost identical in appearance. What was happening is what people, when they landed, when they went to control the flaps, engage the flaps and slow it down, instead they hit the switch for the landing gear. So it wasn't possible to move the controls further apart on the aircraft because these things were already deployed, and once you get stuff into the cockpit, it's hard to move things around. So, in fact, I can't remember if it was Alphonse Chapanis who did this or Paul Fitz. They modified the control by attaching a wedge shape to the control for the flaps and a small rubberized disc to the one that controlled the wheel. So the wedge shape felt like flaps, right? And a small rubberized disc felt like wheels or tires. And now when people reached over, they could actually tell, not only by looking at it, but also by its feel, which one of the controls they had. And this eliminated the so-called pilot error. So that's an early example of how human factors was used, but it recognized a few things. One, that people under stress sometimes make mistakes. Another is that people, when they're confronted with similar kinds of things, often make the wrong choice, right? They make a mistake choosing between two things. A third, that sort of using redundant types of design coding could improve the situation. So now, when they added the small rubberized disc and the wedge shape, people could now look at it and see it, and they could actually touch it and feel it. And in both cases, those things discriminated between the two switches and saved the people an awful lot of lives.